All right, so today we're just going to do, we're going to read an article. Most of you guys, I'm sure, have your Google Classroom open right now. So if you go to your Google Classroom, I posted, no, it's not Bill Nye today. So I'm going to share my screen. On Google Classroom, which I think most of you guys had to go to Google Classroom to get on here. There's no other way. So if you go to classwork and you scroll down to science, I posted something called Models of an Atom Summary. So there's two things that are on that assignment. There's a PDF, which is where the actual article is, and we're going to read that all together. And then there's a Google Doc, and the Google Doc is where you guys are going to type your answers to the questions. So I'm going to not open the PDF. If you left click or right click on the PDF and open it in a new tab, it'll open in a new tab for you. And then if you just click on the Google Doc, it'll open in a new tab. So we'll have both open for you. There's only 4 questions we're going to do today, and you're going to mostly do them on your own. But I'm going to give you guys like a minute. Go ahead and get those pulled up so you have both of them up, okay? I'm going to make sure I have everybody written down. Okay, does everybody see where you pull up the article and all that? Give me a thumbs up if you got it. Cool. We're going to read that whole thing together, so you don't need to worry about reading it just yet. Charles, we're going to read an article. That's what I said. That's what we're doing on Google Classroom. Okay, on Google Classroom, it's called Models of an Atom Summary. So open the PDF, and we'll read that together. And then if you open the Google Doc, oops, that'll open too. So the article is like 3.5 pages. There's a lot of pictures and stuff. And the awesome part is that some of it goes on different things. Let's see. Yeah. It's all right. We'll read it the best we can. Okay, let's focus more on pulling up the stuff than chatting, please. All right. Let's look at the questions first so that we know what we're kind of looking for before we even start reading, because we're going to use the article to answer the questions. So the questions that we're going to answer, you guys are going to do this on your own. So we're going to read it together, but you'll answer these questions on your own. So if you want to write down the answers as we go, it's totally fine. But the first one you're going to answer are, what are the 5 types of models of an atom? So we're going to kind of go through the history of the atom, and there's been 5 different models throughout history. Number 2, where did the different models come from? So kind of like who thought of them, where did they come from? Number 3, what were scientists trying to explain using their models of the atom? So what was the scientific thing that they were trying to explain by creating their models? And then number 4, you guys are going to write a 5-sentence summary, so a short overview of the article, kind of like the summary we did in ELA this morning. Okay, how's that sound? Thumbs up if you're good. Good? Yeah, I have to read it to you guys. Well, I don't have to, but I'm going to read the article to you guys, so just make sure you're following along. You can follow along on my screen if you'd like, or you can read it on your own screen, but that's up to you. Ready? Good? All right, here we go. I'm going to zoom in too. There you go. Model of the atom. Today, we are very familiar with the picture of the atom as a particle with a tiny nucleus at its center and a cloud of electrons orbiting around the nucleus. But where did this model come from? What were scientists trying to explain using their models of the atom? To find out, we have to go back to the early years of the 20th century. So this is what we know of the atom right now. So this blue one is the current model. the colors aren't always those colors, but we have the nucleus in the center, which holds the protons and our neutrons, and these lines around the outside are the electrons that are orbiting around. Okay? So let's go ahead and read the first part, discovering radioactivity and the electron. In the 1890s, most physicists were convinced that matter was made up of atoms. The idea of vast numbers of tiny moving particles could explain many things, including the behavior of gases and differences between chemical elements. Then, in 1896, Henry Becquerel discovered radioactivity. He was investigating uranium salts, many of which glow in the dark. To his surprise, he found that all the uranium containing substances that he tested produced invisible radiation that could blacken photographic paper. What's more, the radiation was constant. There was nothing he could do to speed up or slow down the process. The next year, J.J. Thomson discovered the electron. He was studying cathode rays, glowing beams which streamed out of the negatively charged cathode in a vacuum tube. These beams could be deflected by a magnetic field. And because the beam didn't split up into many thinner beams, Thomson deduced that it was made up of particles of only one type with a negative charge, and all traveling at the same speed. The importance of these two discoveries was that they suggested that atoms were not indestructible. Atoms are tiny, but they are made of still smaller particles. And then this is a picture of a cool light bulb thing. Not exactly sure what it's used for, but the caption says, in this photo, an electron beam is bent along the circular path by a magnetic field. The beam is produced at the bottom in an electron gun and follows a clockwise path inside the evacuated tube. A small amount of gas has been left in the tube. This glows to show the path of the beam. So right now, in this, the beam that's going through, this purple thing, is the path that the electron is taking around the nucleus, which I think is pretty cool. Okay, thumbs up if you're still following me. Still good? Alrighty. Let's keep going. The next part, positive and negative. We already kind of learned about this stuff. Electrons are negatively charged. However, atoms are neutral. So it seems that there must also be a positively charged particle in an atom. So the question was, how are the positive and negative particles arranged inside an atom? Several scientists came up with suggestions, which we now describe as models of the atom. The next 2 pages show 5 different models. Then, on page 12, we consider why the nuclear model was successful. So down here, we're going to go over the next 2 pages. I'm going to zoom out a little bit. Are the 5 different models. This is the answer to number 1, going over these. So you can list these as we go if you want to on your paper or on your Google Doc, or you could do it after. Some of them kind of go on to the second page, like this plum pudding model comes down to here. So we'll have to read that one carefully. But let's start with the dynamic model. So in 1903, is that the first one? Let's see, 1911, 1904, 1904, 1913. Okay. So the dynamic model, that's not dynamic, dynamid, my bad. The dynamid model was discovered in 1903. It was discovered by Philip Leonard. He was a Hungarian-German person. And this is what he drew. This is what he thought it looked like. It was just this blue circle is the particle itself, and inside is your positive and negative subatomic particles, so your protons and your electrons. So he didn't think that there was any neutrons. There's no neutrons yet in this. So the structure of it, the dynamids, each made of an electron bound to a positive charge. Atoms of different elements would be formed of different numbers of dynamids stuck together. 1 for hydrogen, 4 for helium, 12 for carbon. So this explains that different elements have different atomic masses. The problem with it, though, was how did the dynamids stick together to form an atom? So this is the first model that was ever came up with, just that each little circle right here had a positive and negative charge. And that was it. The next model I think the next model goes to this one, the Saturnian model. Okay, I know it's kind of weird, but it's supposed to be like a magazine view, but we can't really show that on here. Okay, still following? Still good? All right, so our second model, it's like Saturn. So the Saturnian model was also in 1904. This one was discovered by Hantaro Nagaoka. He was Japanese. The structure, the electrons form rings around the central positively charged planet, like Saturn. The attraction between opposite charges keeps the electrons in their orbits. So this explains that different elements have rings with different energies, so that they have different colors in their spectra. The problem, though, that there was not enough evidence to support this at the time. So his idea was that there was one positively charged particle in the middle, kind of like how a planet is in the middle, and then all the electrons orbited around the outside, kind of like as if there was a ring, like around Saturn. That's why it's called the Saturnian model. The Saturnian? I don't know, one of the two. Okay? The third model, I'm going to go back up to the one that's split on the pages. So this one splits between the two pages, so we'll have to be careful when we read it. I'm going to scroll back and forth a lot. But this is called the plum pudding model, and it was discovered in 1904. Okay? Not that one, this one. It was discovered by J.J. Thomson, who is British, and it says the structure, electrons equally spaced around a ring, orbiting inside a sphere of positive, this is fun, charge. Later version, the electrons are scattered around the inside, the positive charge, rather than, nope, wrong one. Rather like dried fruit in a Christmas pudding. Whew, this is hard to read, guys. Is it making some sense, though? Following along? Okay. So that was the structure, and this explains that atoms are neutral because positive and negative charges are balanced. So kind of like a battery where you have one positive, one negative, and they balance each other out, or a magnet, how they balance each other out. So this guy is showing that they balance, and it creates a neutral atom. And then the last part, the problem, alpha scattering, which we'll read about on page 12, showed that most of the mass and all of the positive charges were concentrated in a small fraction of the atom. Okay, so that was the issue with that one, that there is still one part that's wrong. There's still a negative part that's happening. But the earlier version of it was that these electrons and all the things were just evenly spaced and went in a circle. And then the later version was kind of like they were all over the place and scattered everywhere, essentially like a plum pudding, which is a British dessert around Christmas time. Okay, I think, let's see, our next one. Yep. Our fourth one is the nuclear model, 1911. It was done by Ernest Rutherford from New Zealand, but it was originally suggested by Jean Perrin from France. This structure is that all of the positive charge of the atom and most of its mass is concentrated at the center with the electrons orbiting around it. This explains that the alpha particle scattering results, which we'll again talk about on page 12. The problem, though, is what holds the nucleus together and why don't the electrons spiral inside the nucleus as well? So on this one, where the plus is where our nucleus is, which we know holds the protons and the neutrons. And then the green things, our electrons, orbit around the outside. Okay, still good? We got one more model to go. Okay. Our last one is the Bohr model from 1913. This was done by Niels Bohr. The structure says that the electrons only in orbits with fixed energies around the center of the nucleus. They can jump from one orbit to the other, emitting or absorbing energy. So this explains that the wavelengths of light emitted by hydrogen atoms, but the problem was that it breaks several laws of physics. paving the way for quantum physics to be developed, which is really high math stuff. Like you have to go like specialize in this stuff. So we're not gonna talk about quantum physics. I don't know anything about quantum physics. That's really hard stuff. But basically, this one, Niels Bohr is saying that there's still that positive center, and the electrons still go around it in circles, but that the electrons can bounce from one ring to the other one. That's what he's saying. So those are our 5 models. And all 5 of those models, you don't have to describe them for number 1, but that's your answer to number 1, right? Telling me all the different models. Okay. What's question number 2? Where do the models come from? So that those 2 pages answer kind of where the models came from as well, trying to explain different things. Number 3 is also very much on that page too, trying to explain the different aspects of physics. Okay, but let's keep reading. We got a little bit left. One last page. Are we still good? Following along? Alrighty. What makes a good scientific model? We'll zoom in again. Models are used in science to help to explain observations and to develop theories. A good model can explain experimental evidence and lead way to a new theory. You can see that each of the atomic models shown on pages 11 and 12, and there were several others, had some pretty good features. They might be able to explain why atoms are stable, why the atoms of one element differ from another, why different elements emit different colors of light, why some atoms decay, and so on. But in the end, a good model must explain everything we know, or it will have to be modified or discarded. So in order for one of those models to be the one that we use to describe what atoms look like and are like today, basically the scientists have to agree on it. So they did decide on one of them that's mainly used, and it's Ernest Rutherford's model. So if we go back up, not this one, not that one, not that one, this one, the nuclear model right here, Ernest Rutherford, this is kind of the most agreed upon version of the atom, where you have your positively charged center and your electrons orbit around the outside. Okay, so this is pretty much the most commonly used and agreed upon model of the atom. So, Ernest Rutherford's most famous experiment involved directing alpha radiation, which are positively charged particles, at a thin gold foil. Some of the alpha particles were scattered back towards their source, and he guessed that the gold atoms had a tiny charged nucleus that reflected them. The nuclear model was rapidly developed by Rutherford and others. A striking feature of Rutherford's thinking is that he realized that it was hard to explain why the nucleus, only made of positive charge, didn't fly apart. Gradually, it came to be understood that the nucleus is made up of 2 types of particles, the protons and the neutrons. And a new force, a strong nuclear force, was discovered that holds these particles together. So the strong nuclear force is what keeps the particles, the protons and the neutrons, inside the nucleus, so it holds them all together there. The nuclear model had another problem. When charged particles, such as electrons, traveled round in circular paths, they usually radiate energy, slow down, and spiral in towards the center of their orbit. Niels Bohr developed the idea that this simply doesn't happen in atoms. Because they have to be in one or because they have to be in one or other of a fixed set of orbits around the nucleus, they cannot be somewhere in between. So spiraling is out of the question. Both Rutherford and Bohr showed that sometimes bold thinking is necessary. They were prepared to discard long-held ideas and move ahead, acknowledging that there were problems still to be solved, but optimistic that they could adapt their models and the ideas they represented to give a deeper understanding of the nature of matter at the level of atoms. Okay? So that's it. Some other scientific models. We'll skip that part. This is an actual picture of what Rutherford's notes looked like with like the the physics that was being used. I can't even read it. It's awful cursive. But these are like his drawings of the different atoms and what they might look like and how he kind of explained it. This is a lot of really hard math right here. I can kind of tell what it is, but that's called calculus, and we're not going to talk about calculus. But so those are your different versions of the model of the atom. That's what I meant to say, sorry. You guys have access to this article. It's still in it's on your Google Classroom. And then you guys have these 4 questions to answer, which the pages, I think it's 11 and 12, which are the purple pages, should answer number 1, 2, and 3 for you. You just might have to think pretty critically about it. And then number 4 here is writing a summary of the article. So what were the most important parts of the article? Okay. That makes sense? How do you guys feel about that? Good? All right. That is actually all we're going to do for science today. So your assignment is to go finish up that the worksheet. I guess it's kind of a worksheet just on Google Docs, right? So that's all we're going to do today. I'll stay on here for another half hour for you guys to ask me any questions and stuff.